Alright, today we are going to finish the arc length and area of a sector notes we did yesterday, and then we are going to, and then we're going to take notes on linear and angular speed, which is the video that how many of you watched last night? How many of you got my remind and watched the video? Nobody? Okay, a couple of us. What? The remind, so it should automatically add you. If you're not added to it, I'll post it in Schoology so y'all can join it. Okay. So if you didn't get it, it's okay. If you didn't watch it, I'll post it it's already posted in Schoology. If you go to watch it tonight, it's just going to reiterate what I am saying. It's the same lesson. I just want you to see it from two different people because it is a little bit confusing. So if you go to Schoology and go to videos, it's right here, the one that says homework video. You can watch that. Okay? So go to Schoology, go to videos. Today we're going to finish our notes on page 4. And then do notes on linear and angular speed. And then flip to page 4 because we got to finish those notes first. Good? Okay. Yesterday we learned 2 new equations for pre-cal for arc length and area of a sector. For arc length, we did arc length equals theta times r. What does theta stand for? It's our angle in radians. So I'm going to add that in because I don't know if that was clear. It is our angle measure in radians. And what does r stand for? The radius. And then we learned the formula for area of a sector is 1/2 theta r squared. We're going to have to memorize both of those. After I do these 2 examples you will be able to do questions 9 through 12. Your homework your homework that I gave you yesterday, Aaron, I put that on your desk. You due Monday is 1 through 16 on a separate sheet of notebook paper, please. Okay? And today you'll have learned everything for 1 through 16. So let's do example 1. If I have a circle with an angle of 30 degrees and a radius of 2 feet, I want to know the arc length and the area of that sector. What are the 2 things I need to know to answer these questions? The radius and theta, right? I need theta and the radius. What is the radius? 2. So right below that, I need to get my water. Right below that, I'm going to write the radius is 2 feet. What is theta? Theta is not 30. Why? Theta has to be radians. So what is 30 degrees in radians? If you put 30, you will get this problem wrong. Be careful. So my arc length is S equals theta R, which is pi over 6 times 2. What is pi over 6 times 2? 2 pi over 6, or pi over 3. Now this is a length, so I need units. What are my units? Feet. And that's my arc length. That's all there is to arc length. Is it really that simple? Yep. What about area of the sector? 1/2 theta R squared. Plug that in. What is that going to give me? 2 squared is, so that's going to be 4 pi over, and on the bottom, the denominator, I have 2 times 6, which is 12. What does that reduce to? Pi over 3. And what's my units this time? Say it louder. Why feet squared? It's area. Are they always going to be the same, like this example? No, this is just happens to be the same. They will not always end up being the same answer. Do I have any questions? All right, I want you to do example 2. Please find the arc length and the area of the sector. What is my theta here? What's my theta here? What? Okay, I'm glad you said that. It is not. And I get why you said it, but that's exactly why I gave you this problem. Do you agree this is already in radians? What are my radians here? It's just 0.25. And I know your brain says, well, that's 1/4 pi over 4. Is there a pi in this? So can you have a radians that is not pi? Sure. So it's just, or you could also write 1/4, but you cannot put pi in here. There is no pi there. Either one of those is right, but not pi over 4. So I'm glad y'all made that mistake so we could learn from that. What about the radius? What's my radius? And then just plug that in. So what is 0.25 times 3? You could have either written 0.75 meters or 3/4 meters. Either one of those would be okay. Do I have any questions? Mistakes allow learning to happen. I'd rather you make the mistake now on the notes than do it on the quiz or test. Alright, what about area of a sector? You can put this in your baby calculator or you can do it in your head. 3 times 3 squared is 9. And then, do y'all agree 0.25 is 1/4 times 1/2 is what is it? That's 1/4, that's 1/2. What's 1/4 times 1/2? 1/8. So it's going to be 9/8. Or if you did it in your calculator, what did y'all get? 1.125. Don't forget to make it meters squared. So either one of those is acceptable. Oh, sorry. Are we okay with arc length and area of a sector? That's questions 9 through 12 on your homework. Okay? Alright, flip over your page when you're done writing that down. And we are now going to do linear and angular speed. How many of y'all are in physics right now? Okay, good chunk of us. I believe y'all are doing like the same thing in physics. I am probably not going to teach it the physics way. Maybe I will. I don't really know how she teaches it. Or he, if you have a he teacher. But I don't know how they teach it. But I'm going to teach it the way I understand it. It might not be the technical way that your physics teacher teaches it, because this is more physics. But I'm going to do this using a conversion chart. So first things first, if you want an in-depth explanation, I highly recommend, I think everybody should, go watch that video I posted. Alright, Miss Nelson does a really good job of explaining it. I am going to break this down into terms that hopefully all of us can understand, and maybe simplify it a little bit, because this isn't always my favorite thing to teach either. So linear and angular speed. The formula for arc length can be used to analyze circular motion. The rate at which an object moves along a circular path is called its linear speed or velocity. The rate at which the object rotates about a fixed point is called its angular speed. So linear speed is measured in units of length per time, and angular speed is measured in units of angle of rotation. So this is how I explain it. Linear speed is a lot like driving, miles per hour. But what does miles per hour actually mean? It means how far did you get in a certain amount of time, right? So, riding a bicycle. This is how I'm going to break down linear speed. Linear speed is a length of the line that you go. So for instance, if I am riding a bicycle and I start right here and I ride, it's basically, let's say I'm riding in sand. It's basically from where I started, the line that I create in the sand, and how long it took me to do that. Do you agree that's a length? That's linear speed. How long did it take you to create that line? Angular speed is not anything about the length. Angular speed wants to know how many times did your tire rotate when you did that. Do you see the difference? So one of them has to do with the length, the distance that you traveled. The other one has to do the rotation of the physical tire and how many degrees or radians it rotates. Are we understanding the difference? Okay, maybe this will help you with physics. Hopefully it'll help you with physics. Alright, so the difference, what I need you to know is, wrong mouse. There is a formula. I'm not going to teach the formula. You're probably going to learn that in another class. I'm going to go straight to converging. So instead of using arc length and using all those things, I'm going to show you how to do this by canceling out what you don't need and getting what you do. Okay? And we are going to need to know this top part. So, what I want you to write on your paper, and by the way, there are different ways to do this. You don't necessarily have to do it my way. This is just, again, what makes sense in my brain more. So, what page are we on? 5? So this is linear. Linear speed is again a distance. It is a line. If I'm going one revolution around a circle, what is that as far as distance goes? When you go one time around the circle, what is that? Okay, that's your rotation. That's an angle. What distance is that though? That's the radians, the circumference. One revolution, y'all are good to go, girls, is the circumference. Watch the video. What's my formula for circumference? Good luck. Have fun. 2 pi r. So for linear speed, one time around is your circumference, 2 pi r. Right? If you were to go on a bicycle, one time around for a wheel, let's say you're on a unicycle, one time around, don't you agree you're going, the length of that line in the sand is the circumference of your wheel? So linear speed is circumference. For angular speed, one revolution is what? The angle is, one revolution is how much? 360, yes, but we're going to do it in radians. So it is 2 pi radians. Okay? If you know this, you can do all the conversions you want. So, we're going to do 3 examples. Example 1. The tire of a bicycle rotates at a rate of 140 revs per minute. The tire of a bicycle rotates at a rate of 140 revs per minute. Find the angular speed in radians per minute. What do I know? I know it's rotating at 140 revs per minute. What do I want to find? Radians per minute. So, do you agree I want minutes on the bottom in my answer? Okay, do I want revs up top? No, I want radians up top. So I am going to put revolutions on the bottom so that they cancel out. And just letting you know, it's always going to be 1 revolution. So 1 revolution is what? Angular speed, what did we say up top? 1 revolution is 2 pi radians. Well, hey, now do I have radians up top? Yeah. So what is my answer here? Multiply it out and you get 280 radians per minute. Nope, that's wrong. 280 pi. Not too bad, right? Is this making more sense, especially those of you that watch the video? A little bit. Okay. B. I want you, if the radius of the tire is 15 inches, I'm just going to write if R equals 15 inches. But if the radius of the bicycle tire is 15 inches, find the linear speed in inches per minute. Okay, what am I going to do this time? What do I know? I know R is 15, but that's actually not going to help me yet. What do I know from the very beginning? It's 140 revs per minute. The bicycle is rotating at 140 revolutions per minute. I know I want to get rid of revs because what do I want? M top. So, and didn't I say 1? Rev is always 1. 1 revolution is what for linear speed? The circumference, 2 pi r. So I'm going to write 2 pi, what's my r? 15 inches. Now I can cross out the revolutions. Am I left with inches over minutes? So what is 140 times 2 pi times 15? What do we get? Don't put pi in. So it's 4,200 pi inches per minute. And that is my linear speed. That's how far that bike travels. What questions can I answer about this? Is this making sense? You're kind of just doing conversions. Alright, let's go with a little bit more difficult one. I want you to try this next one on your own. Example 2. Find the rotation in revs per minute given an angular speed of 6 pi radians per second. Can you go from radians per second to revs per minute? That's what it's asking you to do. I'm giving you radians per second. Can you go to revs per minute? Go. What are you going to start with, and what are you trying to get to? Alright, what was I given? 6 pi radians per second. And what do I need? Revs per minute. So first, what's probably the easiest thing to change? Seconds and minutes. Like we can do that, right? Seconds is on bottom, so I'm going to put it up top because I want to cross it out. And how many seconds are in a minute? 60 seconds are in 1 minute. So we have now crossed out seconds, and we got minutes on bottom. And if you did it equal and then did it again, that's fine. I'm going to do it in one long line. It doesn't matter which way you do it. Now, I want to get rid of the radians on top. And what do I want on top now? Revolutions. Well, we know anytime we have revolutions, what do we put? 1. And this is angular speed. Looking at the top of our paper, angular speed, 1 revolution is 2 pi radians. And now I can cross out radians. Am I left with revs per minute? Yep. So this one's a little working backwards, but it's still the same process. And so what else cancels out? The pi's cancel. So what is 6 times 60? 360 divided by 2. So it's 180 revs per minute. Does this make sense? Are we okay? A little bit weird? Again, if you want a little bit more clarification, that video is going to help you. Last one that I'm going to do is example 3. We get out of here at 37. Okay, I have 10 minutes. Example 3 to me is the most confusing one. It's the one that you are going to see the least, but I need to go over because it's on your homework. Alright, so if on your homework one of the questions asks you to find the radius, given the linear speed v equals 20 inches per second at the rate of rotation 8 revs per minute. This one is not like what we just did, because this one actually gives you your starting point and your answer. Do y'all agree with that? It gives us both the rate and the linear speed. It wants the radius. So, what is our starting point here? Louder? 20 inches per second. What's our ending point here? 8 revs per minute, right? So, I need to turn inches to seconds to revs per minute. How do I do that? Let's go with the obvious. What's the obvious? Get rid of 60 seconds is 1 minute. Cool. How do I turn inches into revs? Remember, this is linear speed. I want revs up top. 1 revolution is what? Look up top of your paper. 1 revolution is 2 pi r. Do I know r? No, that's literally what we're trying to find. Do I now have revs per minute? And so what should that equal? 8 revs per minute. What questions do I have about what I just did? Because it's weird now that you're finding the radius, right? I'm going to take away all of the units. And now I'm just going to make this an equation. Do you agree I have 20 times 60 times 1? Do y'all agree that is 1200? Over, I have 2 pi r equals 8. Do y'all agree that's like the numbers that I have? Can you solve for r? How? How can I get r by itself? You can cross multiply, or I'm just going to multiply both sides by r. But you can cross multiply, you're not wrong. And if I multiply both sides by r, how do I get r by itself? Divide by 8. And then to do that in your baby calculator, because it is a little complicated, do you agree I get 1200 divided by 16 pi? Right? What I would do first is I would do the 1200 divided by 16. Do I need to move it up? Let me see if I can move it up for y'all. Sorry. There you go. I just did in my calculator 1200 divided by 16. Now what do I need to divide by? There's no pi button, but what can I do? What do I get? 23.9. What's my units here? Inches. That one was a lot more confusing and different. Would y'all agree? You're not going to see that on your test. You're going to see that on your homework, and you have your notes for your homework. Alright, you're not going to see that on an assessment either. This is going to be more for homework purposes. As long as you get 1 and 2, that's more your test question type. Okay? Alright, I finished 5 minutes early. Just want to remind you, you can now do all of 1 through 16. Please do it on notebook paper. When is it due? Monday. Alright, so y'all can get started. Oh, the other thing I want to let you know. Can y'all look at your homework? On your homework numbers, I think it's 3 and 4. Or number 3 and 4 negative. They're negative. For when you have a negative angle, if you are finding the radians, your radians should be negative as well. Do not do a coterminal angle and then convert it. You don't need to do that. Just convert it and then your answer will be negative. Does that make sense? Alright, so I had some people trying to make it positive by adding 360 and then convert. Don't do that. Just convert it, your answer will be negative. All right. Thank y'all very much. We're done a little early.